Well, howdy, IB chemistry students. Let's talk about quantitative descriptions of concentration. So the first part is just a little lesson on what the IB language is. In pre-AP chemistry, you probably saw moles per liters, which is molarity. That's what we called it, a capital M. You know how we can write moles divided by liters? Well, if you were to write that all in one line, you could write moles liters to the -1, because -1, a negative exponent, denotes that it's in the denominator, right? So you probably saw that on your summer homework, but hopefully that will help a little bit. Now, one thing that the IB really likes to do is they like to quote things to you in centimeters cubed, and centimeters cubed is a milliliter, and that decimeters cubed is a liter. Make sure you go ahead and read all this stuff. I'm just kind of skimming over it. Now, so that means that moles per decimeters cubed, right, or moles per decimeters cubed, is actually moles per liter, which is all equal to your molarity, all right? Now, never fear, you may still use the capital M, the ML, or the L on your exam or on your papers, whatever, and they will accept that because those are still metric. But they like to quote it to you in moles per decimeters cubed, just like that. So be familiar with reading it. The way we remember the decimeters cubed and the liters is we try to keep things on the DL, right? Keep it on the DL. Okay. All right. So the first part is a percent by mass. So this is super easy, where you just write the mass of the solute divided by the mass of the solute plus the mass of the solvent. So if we're going to calculate the concentration here of 12.5 grams of salt in 625 grams of water, well, that is just going to be 12.5 grams of salt, and then 12.5 grams of your salt plus 625 grams of your water, okay? And then times 100. So forgive me for the pause, but that will give you 1.96%. Okay, that's percent by mass. So that is a way you can write a concentration is in a percent by mass. There is a percent by volume as well, but that's not really covered that well in IB chemistry, not really at all. So they really focus on, well, this is mass per unit volume. So you can do it this way to calculate the concentration of a 0.0040 moles per liter solution of a sodium carbonate solution in grams per decimeters cubed. Well, I just need to know that 0.040 moles per 1 decimeter cubed, right? That's what that means. And now I just need to apply that molar mass. I included your molar mass right here. Remember, this is the relative molar mass. It's 106 grams per mole. And so that's going to be moles of sodium carbonate. And in 1 mole, there is 106 grams. So 0.04 times 106 is going to be 4.24 grams per decimeter cubed. So that's mass per unit volume, grams per liter, or grams per decimeter cubed. Now, the most common one is molarity. That's the one you see, and that's the one we do most of our calculations with. Moles of solute divided by the liters of solution, okay, or decimeters cubed of solution. So if I show it in concentrations, like this guy right here, ammonia, what I'm talking about is the concentration of ammonia. These brackets mean concentration. So calculate the molarity of a solution prepared by dissolving 85 grams of calcium sulfate in enough water to make 600 centimeters cubed of solution. So first, I need to know how many moles that is. So I'll take 85.0 grams of calcium sulfate, and then I'll change grams to moles. Now that's 136 grams per 1 mole. So 85 divided by 136 is 0.625 moles. Now, this is 600 centimeters cubed or 600 milliliters, right? And I need moles per liter, okay, to find the molarity. So what I'm going to do is I'm going to do something real complicated where I will move the decimal place 3 places to the left. Easy shortcut. Take this decimal place, move it 3 places to the left, and you're all of a sudden in liters. See how that works? Hopefully you can remember that little trick. 3 places to the left is an easy conversion. If you want to go the other way, change liters to milliliters, just move it 3 places to the right. You guys are pretty math savvy. I don't have to explain that to you. And then the answer is 1.04 moles per decimeter cube. Excellent. How many grams of KOH are in 2.75 liters? I'll go ahead and just change that to liters of a 0.25 molar KOH. Well, so we want to know grams. So we now know that 0.25 molar, and we know that that is moles over liters. So that's going to be X number of moles divided by 2.75 liters of KOH. That's pretty simple to solve. That will give us 0.6875 moles of KOH. Now I will just change moles to grams. Molar mass is 56. So multiply by 56 and get 38.5 grams. Pretty sweet. So if you're designing a solution, you want a molarity and you know the volume that it's going to be. Like say your volumetric flask it wouldn't be 2.75 liters, it may be 1 liter, but you can do the same type of calculation. You will just solve for X to find the number of moles and then multiply by your molar mass, and you find the mass of the substance that you need to dissolve into the solution. It's pretty simple. So a solution of sodium hydroxide has a concentration of 8 grams per decimeter cube. What is the concentration in moles per decimeter cube? Well, let's find out what 8 grams per 1 decimeter cube. Let's think about it that way. And then let's convert our grams of sodium hydroxide and convert that to moles. Well, that's 40. The relative molar mass is 40 grams per mole. Hey, that's pretty easy, right? And it comes out to be 0.2 moles per decimeter cubed, or it could be 0.2 molar. Hopefully you guys are getting the idea of the IB language. All right, we've got a couple more. What volume of water is needed to make a 0.85 moles per liter solution. Let's call that what it is. It's molarity. Solution of barium nitrate if 10 grams of barium nitrate is used. Hey, if this is getting repetitive for you, that's a good thing. So moles of barium nitrate, so that is going to be 261.3 grams per mole of your barium nitrate. And then now we have, let's see, we want to find the volume. So we have moles and we have molarity. I bet you we can find the volume by just putting the moles right here on bottom and then putting the liters on top. See, that's supposed to be moles per liter, but you can also write it upside down. Just make sure you put the number in front of the moles. See how that works? We'll do that in titrations. You can just flip it upside down if you want the moles to cancel out. See how that works? I hope you see that. The way that one will go is the answer will be 0.045 decimeters cubed or 0.045 liters or 45 milliliters. How fun. Just two more examples. We got 8. Example 7 asks us to calculate the mass of copper 2 sulfate pentahydrate required to prepare 500 centimeters cubed of a 0.4 moles per liter solution. So that's milliliters. We'll call it what it is, and that's molarity. Do that on your test. If you're still those units are still throwing you off, you see the same ones over and over again. Just be able to concentrate and slip those out of your mind. So we know that 500 centimeters cubed is equal to 500 milliliters, which is also equal to 0.500. Let's keep those sig figs liters, right? So now we know that 0.500 liters. We've got our molarity here. I bet you we could use that moles over liters thing to find the number of moles. Notice that the volume times the molarity will give you the number of moles. Very convenient. So the molarity is 0.400 moles per 1 liter, right? So now those liters cancel out. And then now we just need to find the mass. So finding the mass just means that all we have to do is take the moles and convert it to grams. 250 grams per 1 mole. Those moles cancel out, and then our grams left over are 50 grams of copper sulfate pentahydrate. Guys, if y'all had not seen the pentahydrate before, this is a hydrate. This dot water right here, that's what that means. It's been chemically bonded with water, so it has it needs to be included in the molar mass. If you just do copper sulfate, you won't get 250 and you'll get the answer wrong. So you need to understand that the molar mass of water is 18, and then so 5 times 18 needs to get added in to this molar mass right here. I know it's a dot. I know dots normally mean multiplication, but in chemistry, you are going to add. Okay? So 5 times 15, 5 times 18, plus whatever that is. I can't remember. Now, example number 8. What is the concentration of each ion produced when 40 grams of magnesium chloride dissolves in 500 milliliters of water? It asks for the concentration of each ion. All right, remember concentration is the molarity, right? Right? The thing that's in brackets, because I'm going to use those in a second. So 40 grams of magnesium chloride. Well, let's just figure out how many moles that is. Its molar mass is 95.3. So I'm going to divide by the molar mass, grams per 1 mole, right? And get 0.420 moles. Simple enough. Now, it is 0.420 moles per 500 milliliters of water, right? Because 40 grams is in 500 milliliters of water. So this is representative of 40 grams. So I'll make 500 milliliters, or remember 500 milliliters is 0.5 liters, right? So I'm going to put 0.5 liters. You guys see that? That's molarity. Even though the numbers aren't moles per 1 liter, it is still molarity. So I do that mathematical operator and I get 0.84 molar MgCl2. Now really think about this. We have magnesium chloride and it breaks down into Mg2 plus and Cl minus, and there's two of them, right? And so the concentration of MgCl2 we just showed was 0.84 molar. The concentration of magnesium 2 plus 0.84. The concentration of that is actually going to be the same, 0.84 molar. Okay? All you did was split the atoms apart. This magnesium, you still have the same number of magnesiums as you do the number of magnesium chloride atoms. So the molarity stays the same. Then this one is going to be twice of 8.824. So that's going to be 0.824 times 2. So this one is 0.8284 molar. And then this one, chlorine, is going to be 0.84 times 2, which is 1.68.